We have another system in for repair this week, a Sinclair ZX Spectrum Plus 128K. This machine belongs to Jonathan Wickett, aka True, and he has sent us a letter. Hi Glenn, enclosed is the Spectrum 128K toaster, minus the metal grid due to its weight, for you to have a look at. I have recapped the board and replaced the 7805 with a Murata switch mode 5V regulator. One of the radial caps has also been replaced with an axial cap, but with a higher heat rating, which is a mod recommended by Phil at retroleum.co.uk. You will see that I have removed and socketed 3 of the memory chips, which made no difference. I used new old stock memory chips, but that also made no difference. In the other box is the Byte Delight diagnostic cart kit for you, along with a tube of new old stock memory chips, plus 1 old original chip, and some sockets. I'd appreciate it if what you don't use is returned, as I have other speckies that may need them in the future. So Jonathan has been having some problems with his ZX Spectrum Plus. We'll get to this in a minute, but as he said in his letter, in here, well, we have a little anti-static bag with the sockets in it, what looks like the original regulator. There are a pile of RAM chips, and then I assume this is the diagnostic cart kit. This looks like the manual for it, and then the kit itself. Some assembly may be required, so we will see about putting this together later on. But first of all, for now, let's take a closer look at the ZX Spectrum Plus 128K. And considering the sum total of my experience with a ZX Spectrum is, well, nothing more than one of these things. This Spectrum Plus, the first thing that jumps out, obviously, is the keyboard. The system is quite tall off the desk, so not necessarily the nicest thing to type on, but definitely leaps and bounds above the original Spectrum. Although, is it just me, or is the spacing funny here in between some of those keys? I dare say you get used to it though. Taking a quick look around the case itself, because yeah, this is my first time with one of these, so why not? On the front of the case here, there is a socket for a keypad. Does that let you add a numeric keypad to your ZX Spectrum? Nothing much to see on this side, barring a sticker that says 3300. On the back then, things start to look very familiar. The 9V DC input. The Spectrum Edge connector does have RF output, but here's an addition, RGB output. And I suppose this raises a question, how am I going to get a video signal out of this? Because I don't have the RGB cable. I wonder if Jonathan has composite modded this machine. Is the composite mod for this just as simple as it would be on the original Spectrum? On the other side then, we have the tape deck inputs, the ear and the microphone, and then an RS232 port, a serial port. I'm sure that was a welcome addition for many owners of the Spectrum back in the day. There's a button here on the side. I wonder, could that be a reset? Recapped on the 7th of November last year. The other nice addition actually to this case, and I didn't think this machine would have had this, but it's got little stands so that you can angle the keyboard. That does perhaps make it slightly easier again to type on, although I'm still convinced everything is squished or moved up slightly or something. There is something weird about this. But anyway, let's get it over to the bench. We'll take the top off it and let's get a look at what we're dealing with. And I think that's us in. Need to be careful with the keyboard though. I'm sure it has those fragile ribbons on it. No, it's not us in. I've missed a screw. It's a different type of screw, a countersunk one. I have to remember that goes in there. So, oh, the keyboard ribbons aren't connected. That's okay. And we can see there where Jonathan has socketed 4 memory chips. Are they all RAM? Yep, they are. So 4 of them have been put in sockets. Looks like we have a custom ROM in here. He must have wrote his own ROM. All the caps have a little mark on them, a little red mark. A lot of people do that when replacing caps, just to be sure they don't miss anything. So that coincides with the letter. It's been recapped, and there's that other one that's been replaced for a radial cap at 105 degrees. So I don't see anything that might suggest this has had a composite mod done to it. This all looks stock here around the RF modulator. But asking the question over on More Fun Making It's Discord, Lee and a couple of the other guys in there really know their spectrums, so that is the place to go and ask questions. Well, it seems that you can't just composite mod this as simple as you might do a ZX Spectrum, although composite video is provided on pin 1 of the RGB output. So we maybe can hook something up to that. That is, however, getting slightly ahead of ourselves. The first thing I want to do is check the obvious. What's the 3 things a computer needs to run? Power, clock, and reset. Although maybe what we'll do is start actually just with a quick look over the board. Let's just make sure there's nothing obvious. And the reason I say that is the Spectrum Plus board here, much like you would have found on the ZX Spectrum itself, there's no solder mask. And it would be very easy when working on one of these to bridge a couple of traces. And would you look at that? Just at that position there, just at the negative leg of this axial cap, there is a little bridge of solder just from that leg onto that trace beside it. Although, is that meant to be bridged at that point anyway? You know, does that trace come up there and connect in there? I'm not really sure. I think the best thing we could do here is just reflow that. I mean, it looks like it's bridged. Is it definitely bridged? We'll just test it quickly with the multimeter. If I go onto that trace, say there. Yeah, it's on the trace, okay. And yeah, it is definitely bridged to the negative leg of that cap. As I say, I'm not really sure if it's meant to be. It almost looks as if that trace comes up there and then does attach to that leg of that cap at that point, but I'm not sure. Best thing to do would just be to reflow that. And while we're waiting for the iron to heat up here, this must have been something that Jonathan was conscious of, because if we look at this capacitor, it almost looks as if someone has been scraping at the top of the board here around the positive leg of that cap, perhaps trying to remove a little bit of stray solder that was shorting something. But it does all look okay. I don't think there is anything there that is actually shorted. What we'll do is clean that whole area in a minute with some IPA. But first, let's just drop a little bit of flux in there and see about reflowing that point. Right, that looks as if the physical bridge is away there. So let me clean it a bit here with an IPA and a cotton bud. Is the short now gone though? Just testing along the trace. Any connectivity to that leg? No. Okay, one problem fixed, but something that is very easy to do, especially when there's no solder mask protecting all those traces. Okay, I've been over the rest of this board and I don't see anything else. But you know what we should have done before bringing the soldering iron in here? We should have removed this board from the base of the case. That was a bit silly of me, really, wasn't it? Because if I had slipped with the iron, I could have very easily melted something here. Not that I'd ever melt anything while working on a computer. Let's allow us to inspect the bottom side of the board. And at least on this side, Sinclair were kind enough to give us a solder mask. So we shouldn't really have to worry about anything being bridged down here, but we will just quickly inspect the work that was done previously. There was a socket put in there. That all looks okay. Another couple put in here. And they don't look too bad. You can maybe use a wee bit more solder on some of those pins. I mean, it's probably fine as it is, but I always like looking at it rather than looking for it. And by that, what I mean is I always prefer to have a nice little blob of solder on each pin rather than just having the solder sort of flush with the board. Just like to have plenty on there. But yeah, all that work does look okay, to be honest. So just before we do put some power through this, how about we check for any shorts? So I do expect this will be fine. We'll not find any shorts. Jonathan obviously did some work to this, and I'm sure he would have tested for any shorts before trying to power the board up. But let's just be sure, shall we? 9 volts is fed into this machine, and from there both 5 volt and 12 volt are derived. More or less everything on here runs on the 5 volt, and we can check that, say on this chip here, 74LS04. Ground is always that bottom left. 5 volt is always that top right, and we've got about 400 ohms there between them. That's fine. 12 volt makes its way over to this chip, the TEA2000, the video encoder chip. 12 volt is found on pin 11 of that. Ground is on pin 9. So that is pin 9 there. Ground is in that bottom left corner again. Pin 11 or 12 volt would be there. We've got about 1.1k between them. Again, that's fine. Shall we put some power through this and measure those voltage levels? I do have an original Sinclair power brick here. This is the one that I was using for my ZX Spectrum. But I think this power supply might actually belong to this machine. It is 1.4 amp rated PSU. I'm fairly sure that is the one for this thing. So power on. Let's bring the multimeter back in. We can have a look at our 5 volt level just on the same 7.4 chip. And 4.92, 4.93, that's fine. What about 12 volt? That's maybe a little bit low. Is it 11.19? Slightly on the low side, 11.2 there. But you know what? It might actually be okay. So the other two things I wanted to check for was a clock and a reset. Let's just take a look for that reset first of all. And just because I have the logic probe handy, we'll test for reset on the CPU, Zilog Z80. Reset can be found on pin 26. And it is an active low signal on the Z80. So we should see it start out low, then go high. 40 pin dip. So 21, 22, 23, 24, 25, 26. And yeah, okay, it was low for a split second there, and then it jumped up high. So reset probably is okay. The clock to the Z80 comes into pin 6. And yeah, that's fine. Now we could break out the oscilloscope to measure that clock, but we see it pulsing there on this. So let's just assume that it's good. How about we try and pick up a video signal? And as I said, we get that from pin 1 of the RGB output. Easiest thing to do would probably be just to make off a cable to the solder points here on the bottom. The composite video signal comes out of the emitter of transistor 14, TR14. That is the solder points of it there. I think that one is the emitter because it runs through to a 75 ohm resistor. So there's a trace coming down there to that point. I think that is the 75 ohm resistor across there. Yep. And then there's a trace from that up to one of the points on that DIN socket. That one must be pin 1. So I'll hook up video from there. And we'll need to pick up ground as well. I'm sure we can just get that handy there. From this large ground plane here, that's the can of the RF modulator coming through onto that. Give me a second to hook that up and then we'll test it. So an old AV cable just cut up, signal to pin 1 there, ground 2 there, a little bit of Captain tape here just for some strain relief. Do we get a video signal? Yes we do, and it seems as if the Spectrum has booted. Jonathan thought the problem with this machine was the RAM, but all we've done is fix a little solder bridge on the ground of that capacitor, and it certainly seems as if this machine is working fine. Now maybe there is another fault, maybe there is something else, but at the minute, yeah, it all seems good. I wonder, could I reintroduce that short at that point just to see what that does to the screen. I might just use my tweezers here, use them to bridge that point there. Ah, look at that. It brings up a striped pattern on the screen. I think you could be excused for thinking that said striped pattern was a RAM fault, but it appears that the only problem this machine had was that bridge. Let's hook up the keyboard. Okay, if we go into 128 Basic, that seems to work. It's all good. Yep, all good. I think we have one fully working keyboard here. No issues from that point of view. So quick power cycle, and let's go for that famous first program. Get it to do something simple for now. Yeah, it works fine. Must have just been that bridged point. Now Jonathan did fit a couple of new RAM chips here, and he did say there was one old chip included. Let's see if we can find that. I assume it's this first one here, as it's got solder all over the legs of it. So we'll swap that into, say, that position. And let's try it again. Yeah, still working fine. That was an easy fix. I suppose the lesson here is double check your own work. But at least this Spectrum Plus 128K, that seems to be it sorted. Although we do have one other thing to do, don't we? And said other thing might let us test this a bit more thoroughly. Let's put together the diagnostic cart. So what a lovely wee kit. All the components are bagged individually here and numbered. I would assume we start with bag number 1. The board itself, the surface mount work, that's all been done for us. So it's only through-hole stuff. It does come with this manual, ZX diagnostic cart. Now with 3D printed standoff, this thing, hey, that's flexible. What type of 3D print material is that then? Which is flexible? Because that's pretty cool. The manual, I assume, tells us how to use the diagnostic cart, so we'll need to have a read at that later. There's something that's very cool. A schematic diagram of the cart itself. That's something you don't see very often these days with any new bits of hardware. There is the assembly instructions. Although it does seem pretty straightforward because, as I said, everything has been so well labelled. So, bag number 1, D1 Zener diode. The legs of it are pre-bent and all. D1 goes in there. The line on the symbol on the silk screen, just match that up with the line on the diode itself. That goes in like that. One down. Lots to go. Time for a soldering montage. Bag 2. Okay, so jumper 1. When a jumper is on pins 1, 2, it will enable the integrated diagnostic software. That's what we want. So that will go on there. If that jumper is moved to position 2, 3, the Spectrum will boot as normal. Jumper 2. When a jumper is on pins 1, 2, it will ignore the M1 line in case it's not working properly. What's the M1 line? When a jumper is on pins 2, 3, it will use the M1 line. Of course, when the M1 line of the Z80 CPU is failing, okay, it must be something to do with the CPU, the Z80 must be replaced. So I assume we'll just put that on position 2, 3, because presumably we want to use the M1 line. And then the other jumper here. This jumper is for compatibility with Brazilian clones that use this line for audio. When using a Brazilian ZX Spectrum clone, disable the jumper, enable this jumper for original models. Okay, so that goes on there. The switch up here though, the slider switch, slide it to the right to have the red middle row LEDs show the status of data lines present on the edge connector. Those ones, and yeah, it is to the right. Slide it to the left to have the red LEDs show the diagnostic mode. Well, we want the diagnostic mode. In the diagnostic mode, the ZX cart will first show the LEDs counting down when the system is powered on. This will make sure the LEDs are working properly. When an error in lower RAM is found, it will indicate which of the 8 lower RAM chips is probably defective by showing its data line number. You can use the lower RAM location picture in one of the next paragraphs to find its corresponding chip. Also in this diagnostic mode, the red middle row LEDs will also show the interrupt counter, counting quickly at the end of the software tests. Okay, let's test it. But I mustn't forget the little stand. That goes on there. The cartridge is keyed. It can only go on that direction. In fact, there's a slot there on the board. And up in there, it almost looks like something's been stuck through this edge connector. In fact, it almost looks like a nail has been melted through that. But I suppose whatever works, it stops you putting this on upside down. But does it work? Do we get a light show? Yes, we do. And there's those LEDs counting down, like it said it would in the manual. Plus we're getting some funkiness on the screen. I can only assume all that's normal. And okay, the ZX Spectrum diagnostics. So lower 16K RAM, that's passed. Spectrum 128K UK ROM, that's passed. And now it's testing RAM banks. That composite video signal is awful, isn't it? Although I dare say with a proper RGB cable, you'd probably get a better composite video signal, and you'll definitely get a nice clear RGB video signal. But while I was waffling on there, the RAM bank testing, that all passed, as did the paging test. Presumably that passed okay. 128K RAM test pass, so yeah. Tested the interrupts. That's all good. And now it's paging in the Spectrum ROM. And it's booted. Is that it? Is that one clean bill of health for our Spectrum Plus 128K? It certainly would appear to be. Well, there we are. One Sinclair ZX Spectrum Plus 128K up and running again. Quite a simple fix in the end. But sometimes it does just need an extra pair of eyes to catch something like that. Jonathan definitely can be forgiven for thinking it was a RAM fault. That sort of zebra stripe pattern on the screen, yeah, if I had seen that, I definitely would have associated that with a RAM fault as well. And it's certainly easy to get dragged down a rabbit hole looking for a fault in one location when in reality the fault is something completely different somewhere else. In this case, it was just that little bridge between the negative leg of that cap and whatever that trace was beside it. But that's it sorted now. I will get this boxed up and on its way back to Jonathan, and hopefully he can get some enjoyment out of his ZX Spectrum Plus. He is letting me keep the diagnostic cartridge, so that is fantastic, and thank you very much, because that is a very generous donation. I'm sure that will come in handy somewhere down the line should I ever get another Spectrum to repair here on the channel. But that's it for now. So hopefully you enjoyed what you've seen. If you did, I would appreciate a thumbs up. Why not hit subscribe if you haven't done so already? Still plenty more yet to come here on CRG, and I'll see you next time.